Alright, I hope you came prepared to work because I need your help in this clip. You and I are going to compare two fast food restaurants by determining the interquartile range for each of them. Let's get started. I'll show you the example. Students kept track of the wait times for two different fast food restaurants. Calculate the interquartile ranges of both restaurants in order to compare waiting times. So I've been given the wait times for one restaurant, and you're going to get the wait times for the other restaurant, and we'll work together to compare which one has the faster waiting times. My restaurant's called Happy Burger, and I have a list of some random wait times that look like that. Now I need to compute the interquartile range for that list of wait times. So how do I do that? Well, let me show you. The first thing I'll do is rearrange all of these times from lowest to highest, and I'm doing that because essentially the interquartile range is all about finding the median 3 times. And medians, well, we need to line up our numbers from lowest to highest first and find the middle. So I'm going to just start writing out these numbers from lowest to highest. So it looks like the lowest number there is 0.4. That's pretty fast for a restaurant. Then we have 0.9. Then looks like 2.9 is next. And I'm just going to keep doing that until I've listed all the numbers. And when you're doing this, it might actually help you just to cross out the numbers on your list that you've already used. So let's fill in the rest. Alright, so there we go. It's a bit of grudge work, but I took the time to rearrange all my numbers starting from the lowest to the highest. And I counted up. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 numbers in total. And that's good. I crossed off everything off my list. Let's move on to step 2. In this next step, what I need to do is find the median of this list. Or in other words, where's the middle? Where does the list get split into 2? Well, since I have 20 numbers in total, I'm going to have 10 to the left of the middle and 10 to the right of the middle. The middle, it turns out, is going to be right here, right in between 7.3 and 7.4. Right sandwiched in there. And that's going to be called Q2, or quartile 2. And its value will be the midpoint between 7.3 and 7.4, which is 7.35. Now I can see if I count, I've got 10 numbers here and 10 numbers here. So that is in fact right smack in the middle of that list. Let's move on to step 3. In step 3, I'm going to label the median of the first half. I'm going to call it Q1. So essentially I'm doing the exact same thing I did in step 2. I'm finding the middle, but only of these first 10 numbers. I'm ignoring the bottom part of the list. So just find the middle of the first 10 numbers. Well, since there's 10, I'm going to be sandwiched right in between here, it looks like. That will be Q1. Because now I have 1, 2, 3, 4, 5 to the top and 1, 2, 3, 4, 5 numbers to the bottom. So that's right smack in the middle. But I need to find the midpoint between 3.7 and 5.2. Well, if you remember, to find the midpoint, you just add the two numbers together and divide by 2. Like this. And this will give me 8.9 divided by 2, which if you need to use your calculator, that's fine, but it's 4.45. Okay, 2 more steps to go. In the 4th step, we repeat exactly what we did in the 3rd step. We're just going to look at the bottom half of the list this time, and we're going to ignore the top. So we need to find the middle of these bottom 10 numbers. And it looks like this one will be a little bit easier because the split is right here, right in between an 8.9 and, well, another 8.9. So it'll be right there. And as you can probably guess, we'll call that Q3. And there's no calculation needed. The midpoint for those two numbers is, well, it's the same thing, 8.9. Now we've got Q1, Q2, and Q3. Remember those steps? Because I'm going to get you to try them really soon. Now that we labeled all 3 quartiles, or medians, the interquartile range is the distance between Q3 and Q1. And the way you find the distance between two numbers is just subtraction. So the interquartile range will be Q3, which is 8.9, subtract Q1, which we found to be 4.45. And that will give us the range. And that math turns out to be 4.45. I'm just going to say IQR for interquartile range is equal to 4.45. And I'm going to highlight that so that you and I can compare our answers in just a minute. All right, so now it's your turn. I'm going to put you to work so you can help me out here. I've done the calculations for Happy Burger, but now it's your turn to tackle Chicken Shack. Here is the list of waiting times for Chicken Shack. So follow the steps I showed you here on the left and try and find the interquartile range for those numbers. So how did your work go with Chicken Shack? Well, hopefully you found out that the interquartile range was 2.25. And we found that by first writing out our numbers lowest to highest. Then we found all three quartiles. And the interquartile range is just Q3 minus Q1 to get 2.25. But what does this tell us? What can we do with this number, 2.25 for Chicken Shack, compared to 4.45 for Happy Burger? Well, which restaurant do you think had the shortest waiting times on average? Probably yours, probably Chicken Shack, because the median, Q2, was 4.55. Q2 for Happy Burger was 7.35. So people on average waited less time. How about the range? What does that tell us? 2.25 versus 4.45. Well, the smaller the interquartile range, the more bunched in all of these numbers are. So what it means is the wait times were more consistent at Chicken Shack than at Happy Burger. Because this range is larger, it means the wait times are more spread out. They're not bunched together as closely. So Happy Burger is a little more inconsistent with getting the food to the customer. So you might say that in a perfect fast food restaurant, the interquartile range would be almost zero. All the wait times would be very consistent. You get your food out at the exact same time. And the median would be as low as possible to get the food out as quickly as possible. There you go. There's an example of how you would use the interquartile range to compare some data.